Let's use tree diagrams to solve some problems. These problems are very common in probability. Sometimes they call them pom-poms, or sometimes they call them marbles, or blocks, or cubes, or whatever, but the idea is always about the same. So you have a bag or a container of items, sometimes, like I said, pom-poms, marbles, cubes, blocks. In this case, 3 are white and 4 of them are colors. So they could be just black or red or blue or green, you can see. But that's our delineation. 3 are white and then 4 are colored. I pick one pom-pom out and without looking at it, and then I put it back in the bag. Then I pick out another pom-pom. What's the probability that I pick out a white pom-pom and a colored pom-pom? So I've given you a framework here of a tree diagram, and I've just called them counter 1 and counter 2 instead of pom-pom 1 and pom-pom 2. Notice that with our first draw out of this bag, we're either going to get a white one or a colored one, and we can determine these probabilities. So what's the probability we're going to get a white one? Well, there's 3 out of a total of 7. So I could write 3/7 right here on this line. Well, what's the probability that the counter that I pull out is going to be a colored one? Well, there's 1, 2, 3, 4. So I would write 4 out of 7. Notice that 3 out of 7 and 4 out of 7 sum to 1, or 7 out of 7. Then I'm going to proceed to the second draw out of the bag. The key to this one is notice that it says I put it back in the bag. So my sample size is not changing. On this second draw, I'm still going to have 7 counters or pom-poms in the bag. So my probability is going to be 3 out of 7. My probability of getting a colored one is 4 out of 7. And the same thing on the second part of the branch, because that's the part that says I got a colored one on the first draw. So I would put 3 out of 7 here and 4 out of 7 here. Then I can follow along a branch and compute my total outcomes. So the probability that the first one is white and the second one is white, well, that would be 3 out of 7 times 3 out of 7. Remember, we're going to multiply here. So we would get 9 out of 49. You can continue that, and I'll show you what the outcomes look on the next slide. There you go. There's all of our outcomes with our probabilities put in. Notice that if we add up all these probabilities, 9 over 49 plus 12 over 49 plus 12 over 49 plus 16 over 49, we get 49 over 49, which is 1. That's a nice way for you to double check that you did your tree diagram right. You can check along your branches as well. Right here, these sum to 1, these sum to 1, and our first ones sum to 1. Now let's answer the question that was asked. What's the probability that I picked a white pom-pom out and a colored pom-pom out? But it doesn't say that order matters. It doesn't say I had to pick the white one out first and then the colored marble out next. I could have picked them in either order. So these are the 2 outcomes that meet that criteria. The white one first and then the colored one, or the colored one first and then the white one. So now I'm going to add these 2 separate outcomes. So 12 over 49 plus 12 over 49 equals 24 out of 49. That's an example with replacement. I put the marble or the counter or the pom-pom back in the bag.